Hello everyone, I'm Natasha and welcome back. So today we're going to continue our chapter number 2, relations and functions. So in the last video we discussed about the Cartesian product of sets, which is also known as a cross product of sets. Like we say the cross product of vectors, it is just like the same, but it is the cross product of sets. Okay, so in this video, we're gonna talk about some few things. Those all things are going to be, they will be all related to the ordered pairs, triplets, and yeah, today we're gonna discuss about ordered triplets, and maybe we're also going to discuss about relation. Yeah, mainly about relations, because this is the main thing that we're gonna start our chapter from. So whatever it is, so let's get started. Okay, so first thing is about the ordered pairs. So two ordered pairs can be equal. Now let's see how. So first of all, I'm going to write an example and then I'm just going to, discuss it with you. Okay, so first thing that I'm going to write is, okay, let's take an easy example, and I just want to tell you something. Okay, yeah, whatever. Okay, so it is, let's say we have two ordered pairs. Okay, first is x and y, and the second one I'm going to take is maybe u and v. So can two ordered pairs be equal? Like, I just want to say that can these pairs be equal? Are they going to be equal? So question is that two ordered pairs can be equal or not. So whatever it is, so let's discuss. So of course it can be equal. So I can say that two ordered pairs, they're like equal. How? So two ordered pairs are equal if and only if the corresponding first elements are equal and the second elements are also equal. So what does that mean? So corresponding first elements and the second elements both, both should be equal. So it's trying to say is that if and only. So two ordered pairs are equal if and only x is equal to u and y is equal to v. So what is it trying to say? So it's trying to say that two ordered pairs are equal if and only if the corresponding first elements are equal and second elements are also equal. So they should be equal. Both the corresponding elements should be equal. So the first one also and the second one also. If they're equal, this means that we can say that those ordered pairs are equal. Okay, so now the second thing. Okay, so now the second point that I'm going to discuss is related to something. It's actually related to Cartesian product of sets. So what is it? So let's say if number of elements in set A is equal to P. Okay, if number of elements in set A is equal to P and number of elements in set B is equal to Q. So so what we can say is that then the number of elements in A cross B is equal to P into Q. What is it? Well, what does this statement mean? So what is it trying to tell us? So it's saying that if number of elements in set A is equal to P and the number of elements in set B is equal to Q, then the number of elements in A cross B is equal to I can say the product of P and Q. So, like, for example, if we have the number of elements in set A is equal to, okay, so let's say, for example, that was the main example actually, and I'm going to take another one example. So, in this one, I'm going to use actually the numbers, not the, alphabets or variables, okay? I'm going to use the constant. So, yeah, the numbers. Okay, so let's say the number of elements in set A is equal to, what should I say, maybe 8. And the number of elements in set B is equal to 4. So, what if I have to find the number of elements in A cross B? Then what is it going to be? So how can I, get the answer? Like how many elements are gonna be in A cross B? So how can I find? By doing their multiplication, I can say 8 into 4. So 8 into 4 is actually going to be 32, isn't it? So the number of elements in A cross B is going to be 32. So if in some conditions or in some questions, if number of elements in set A, or if there's any other set, that doesn't matter. But if we have to find the Cartesian product of both of those sets, so then what are we going to do? So first of all, we'll have to know the number of elements in both the sets, we have. So then after we can, we'll multiply both the numbers, the number of elements in set A and the number of elements in set B, and whatever answer we're going to get, that's going to be that's how we can get the answer. So what does that mean? So the number of elements in A cross B is equal to 32. Okay, 32. So this is just simple. So it's just mainly the statement, this statement mainly trying to say this thing. So how can we find the number of elements in A cross B? Like how can we find the number of elements if they're given in the Cartesian product? Okay, so let's move on to our third point. The third statement we have is about ordered triplets. Do you know about ordered triplets? If not, then let's discuss it. Okay, so ordered triplets. So let's say I've said A. So A cross A is equal to A, comma B, comma C belongs to the real numbers. Okay, let's have a look at this. Is it right? So can I just take it as an example? Or should I change it? Okay, I'm going to change it in something else. Okay, I'm going to change it a little bit. So what I'm going to write is going to be a little different. Okay, so let me rub these things. Ordered triplets. So mainly if you're gonna hear this word, ordered triplets. Triplets is like twin triplet. We have once, twice, thrice. So it's the same like the triplet. Double, triple, isn't it? Double, triple we have. So triplet is like, it's saying about ordered triplets. So ordered triplets means, well actually we can guess. So ordered triplets. Ordered triplet means ordered. Ordered means something about, we're talking something about, let's say we're talking about the sets which are ordered. But yeah, they're ordered in the triplet form. Triplet means in number of 3. So, okay, so I took A cross A cross A. This is what I will call, this is actually the Cartesian product. Yeah, this is actually the Cartesian product. and is equal to, what I can say such that A, B, and C. Okay, so A, B, and C. A, B, and C such that all these three, what should I say, or numbers or whatever, I'll say, let's say elements. So all these elements belong to set A. Okay, so what does that mean? So it is trying to say that, yeah, so A into A into A, which means A cross A, A cross A is equal to, the elements we have is A, B, and C, which belongs to A. So in this, it is in set builder form, as we can see clearly. So yeah, what we'll say is that A, B, and C, A, B, and C, these all elements are called ordered triplets. Okay. Okay, so A, B, C, the three elements that we have, they're actually, A, B, C are called ordered triplet, or I can say that, okay, let me change a little bit. Yeah, I'm going to change a little bit so that it will, and yeah, I want to take it in the normal way. Yeah, in the normal. Okay, so I'm going to again drop it, and I'm going to write it in the simple way. Simplest way that I'm going to use, so that no one will be confused or anything else. So here A, B, and C is called an ordered triplet. Okay, what does that mean? So it is saying that the cross product of set A with itself three times, is equal to the elements A, B, C we have. So what is it trying to say? So the elements A, B, C, they actually belong to set A. So what I'll say is that the A, B, C is actually called, this is what we'll call the ordered triplet. Not the A cross A, A cross A cross A. No, the elements, the elements that will belong to the set we have written. So those elements will actually, will be known as a ordered triplet. So whatever elements that we're going to have, they're actually going to be the ordered triplet. And in this one, like it is saying, it is an ordered triplet in the number of 3. It is a triplet and a cross product of set with itself. That's what we can see. Okay, so those were the 3 points that I wanted to discuss, so let's move on to our next topic. It is relation. We're going to discuss about the relation. A little bit about relation. So relation is, the relation we have with our family, relatives, whatever it is a normal relation in that we'll talk about. But in maths, it is actually a different relation. But yeah, it's actually a relation type, but it is a relation of sets. So a relation between two sets is an ordered, Okay, so a relation between two sets is a collection of ordered pairs containing one object So a relation between two sets is a collection of ordered pairs containing one object from each set. So a relation between two sets is a collection of ordered pairs containing one object from each set. So what is it talking about, the relation? So relation, like we talk about these relations, isn't it? So this is what I'll call, they're in a relation with each other. So a relation between two sets is a collection of ordered pairs containing one object from each set. Okay, so in simple language, it is talking about the relation between the two sets. So the relation between the two sets, there is just mainly a collection of ordered pairs that we have, which is it's containing one object from each set. Like we have 2 sets, 3 sets, how many number of sets, that doesn't matter. But they're like whatever their relation having between each other. So this is what relation means in maths, of course, in maths. So that's all for today, and in the next video, of course, we're going to discuss about the relation. And I'm also going to take an example, and we're going to solve some questions also, and a lot of things. So that's all for today, and in the next video, of course, we're going to discuss about the relation, and we're going to solve some questions also. So we're going to do a lot of things, so it's going to be fun. So see you in the next video. So thanks for watching, and have a great day.